This is a key to the makeup for test number 2. In problem 1, you're dividing these two complex numbers and you're asked to write in the form a plus bi. Now when dividing two complex numbers, the goal is to get rid of this I that's in the denominator. So you don't want an I in the denominator. You don't want that imaginary unit that's in the denominator. So one way to do that, since this is a binomial, one way to do that is to multiply. I'm going to go ahead and rewrite this over. So you're going to multiply both numerator and denominator by the conjugate of the denominator. And so the conjugate of 6 minus 2i is 6 plus 2i. So you multiply both numerator and denominator by 6 plus 2i. Now let's go ahead and multiply these two fractions. And so I'm going to write this as one fraction. So I have in the numerator 4 plus 3i times 6 plus 2i. And in the denominator, I have 6 minus 2i times 6 plus 2i. Alright, and then that's going to equal, alright, I'm going to go ahead and FOIL this. So when I FOIL that, let me go ahead and expand this. So when I FOIL that, I'm going to get 4 times 6 is 24. The outer, 4 times 2i is 8i. The inner, 3i times 6 is 18i. And then 3i times 2i is 6i squared. The denominator, now remember, one of the things about the denominator is that these are conjugates of each other. So when you multiply this, the outer and the inner will be opposites. So when you add those up, you're going to get 0. And so if you use the FOIL, you'll get 6 times 6 is 36. The outer is a positive 12i. The inner is a negative 12i. And the last, a negative 2i times a positive 2i is a negative 4i squared. All right, now I'm going to go ahead and write that above here. So combining like terms in the numerator, at this point I have 24. 8i plus 18i is 26i. And I'm going to go ahead and remind you that I squared, remember I squared is equal to a negative 1. And so I'm going to write this as plus 6 times a negative 1. So I just replace the I squared with negative 1. In the denominator, remember we just discussed, the 12i and negative 12i are opposite. So when you add those up, you're going to get 0. And so I get 36 minus 4. And again, I squared is equal to negative 1. So I get minus 4 times negative 1. Simplifying what I can in the numerator, I have 24 plus, and that's supposed to be 26i by the way, plus 26i. 6 times a negative 1 is a negative 6 divided by 36, and then negative 4 times negative 1 is a positive 4 equal, and then 24 subtract 6 is going to give us 18 plus 26i divided by, and then 36 plus 4 is 40. And then in the form a plus bi, I'm going to get 18 divided by 40 plus 26 divided by 40i, and then reduced, I'm going to get 18 40ths is 9 20ths plus, and then 26 divided by 40 I can write as 13 divided by 20i. Okay, so that is the answer for number 1. Now number 2, you want to solve the following quadratic equation. And I'm going to just go ahead and use the quadratic formula. But if I'm going to use a quadratic formula, I need to go ahead and write this in standard form. So I'm going to get 2x squared minus 4x plus 3 equals 0. So now a is the coefficient of x squared, so a is 2. B is a coefficient of x, so that's negative 4. And c is your constant, and that's 3. And I'm just going to go ahead and substitute this information into the formula. So I get x equals the opposite of b. Well, if b is negative 4, the opposite of negative 4 is a positive 4. Plus or minus b squared. So if b is negative 4, I got to square that. Minus 4 times a is 2, times c, which is 3. All of that is being divided by 2 times a, which is 2. All right, now simplifying the discriminant, which is this radicand, I have 4 plus or minus the square root of. Negative 4 times itself is 16. Negative 4 times 2 times 3 is 24, so I get minus 24. divided by, and then 2 times 2 is 4. And so I get 4 plus or minus the square root of 16 subtract negative 24. I'm sorry, 16 subtract 24 is a negative 8 divided by 4. Now let's go ahead and simplify the square root of negative 8. So let's go ahead and talk about that. Square root of a negative 8, I can write that as square root of a negative 1 times the square root of 8. Square root of a negative 1 is defined to be the imaginary unit I. The square root of 8 I can simplify because 4 is the largest perfect square that goes into 8, so that becomes the square root of 4 times the square root of 2, and the square root of 4 is 2. So I'm going to rewrite this as 2I square root of 2. So that's going to go here. So I get 4 plus or minus 2I square root of 2 divided by 4. And we can actually go further with that in terms of simplifying because 4, 2, and 4, those are all divisible by 2. So I get 4 divided by 2 is 2, plus or minus 2I square root of 2 divided by 2 is just I square root of 2, and then 4 divided by 2 is 2. So I can write it like this, and if I want to write it as two separate fractions, I would have 2 divided by 2, which is 1, plus or minus, and then 1 half I square root of 2. All right, and again, you can also write it in two separate solutions. So you could say something like one of them would be, I mean, there are multiple ways you could do this. 2 plus this, I square root of 2 divided by 2, comma, 2 minus I square root of 2 divided by 2. So these are all different ways of writing that answer, writing the solutions. All right, so that was number 2. Okay, let's look at number 3. Now, number 3, you want to solve this quadratic equation, but you want to use the square root property. All right, so just make sure you're following the directions. So if I'm going to use the square root property, I first of all have to get this squared term by itself. And so I'm going to get 5x plus 2 squared. I'm going to have to subtract 1 is equal to 12. All right, then I could use the square root property. Once that expression is being squared by itself, I can take the square root of both sides. So when I do that, remember, you have that plus or minus you have to think of. So the square and the square root undo each other, so I get 5x plus 2 equal plus or minus the square root of 12. Now, let's go ahead and simplify the square root of 12. So the square root of 12, the largest perfect square that goes into 12 is 4, so that becomes the square root of 4 times the square root of 3. The square root of 4 is 2, so this is 2 square root of 3. And so I'm going to put that here. So I get 5x plus 2 equals plus or minus 2 square root of 3. And then I'm just going to go ahead and get x by itself, so I'm going to subtract 2 from both sides. And when I subtract 2 from both sides, this is what you get. 5x equal, this is 0 right here, negative 2 plus or minus 2 square root of 3. And then dividing both sides by 5, 5 divided by 5 is 1. I get x equal negative 2 plus or minus 2 square root of 3 divided by 5. And you can leave your answer like that. Now if you want to write it as two separate solutions, you can. You could say negative 2 plus 2 square root of 3 divided by 5, comma, negative 2 minus 2 square root of 3 divided by 5. Okay? So either one's fine. Okay, number 4, you want to solve this radical equation. Notice though that is a square root. And when solving a radical equation, the process is to get the radical by itself if you can, and I can here. In fact, the radical is already by itself. Once the radical is by itself, you want to get rid of that square root symbol. And so one way to get rid of that square root symbol is to raise both sides to a power equal to the index. Since this is square root, we're going to square both sides. All right, and so now let's go ahead and simplify what we have. 3x times itself is 9x squared equal, and then when I'm squaring the square root, those undo each other, so you're left with 8x plus 1. So notice I went from a square root equation to a quadratic equation. Now those are two different equations. Keep that in mind. This is square root. This is quadratic. All right, so keep in mind we have to look to see if we have any extraneous roots. So whenever you raise both sides to an even power, you could introduce extraneous roots. Okay, so let's go ahead and put this in standard form. So I got 9x squared minus 8x minus 1 equals 0. And this is factorable. You could use the quadratic formula if you want to. It's up to you. But it is factorable, so I'm going to go ahead and use the, I'm going to go ahead and factor this. So when I factor this, I'm going to get 9x plus 1 times x minus 1 equals 0. And then using a zero factor property, I get 9x plus 1 equals 0, x minus 1 equals 0. And then notice I went from a square root equation to a quadratic equation to two linear equations. And so if I solve this linear equation, I get x to be a negative 1/9. Over here, I get x to be 1. All right, now remember these are my proposed solutions. Okay, so these are proposed solutions. So I know I'm calling these proposed solutions. Proposed solutions. So I know that these solutions are solutions to this linear equation and they are solutions to this quadratic. But they may not be solutions to the radical because I raised both sides to even power, and so I need to check. So we have to check for extraneous roots. We got to check and see if any of these are false solutions. All right, we know it's a solution here, but it may not be a solution to the original. All right, so let's check. So you have to check this. You are told to check. So check. Let's check the first one. X equal negative 1/9. And we got to go back to the original problem, which is this. So we have 3x equal the square root of 8x plus 1. All right, so wherever we see the variable x, I'm going to substitute negative 1/9. So I get 3 times a negative 1/9. And I want to see if that's going to equal the square root of 8 times a negative 1/9 plus 1. Well, 3 times a negative 1/9 is a negative 3/9 equal. And in the square root, this is negative 8/9. Negative 8/9 plus 1 is 1/9. Okay? 1/9. All right, I'm sorry. Yeah, okay. So, and then negative 3/9 I can reduce. So that's going to be negative 1/3. All right, now so this is negative 1/3, right? Negative 3/9 reduced to negative 1/3. But be careful. The square root of 1/9 is only 1/3, and notice those two are not equal. So what we found is that this right here is an extraneous root. That's an extraneous solution. Now that's not a solution to the problem. It's just an extraneous solution. So by raising both sides to an even power, I introduced I introduced a solution that's a solution to something in this process, but not a solution to the original. Now you got to check x equal 1. So x equal 1, do the same thing. 3x equal the square root of 8x plus 1. Wherever we see the variable x, I substitute 1, so I get 3 times 1. And I want to see that's going to equal the square root of 8 times 1 plus 1. Well, 3 times 1 is 3. Over here, this is the square root of 8 times 1 is 8. 8 plus 1 is 9, right? And then square root of 9 is 3. And notice that those are equal. So the only solution is x equal 1. So x equal 1 is the only solution. All right. So this is what you have to show, though. You had to show why this did not work, why this was extraneous. All right, so that's why I gave you a hint. Show that you checked for extraneous roots. All right, or extraneous solutions. All right, so that's number 4. Now, number 5, you are asked to do this in number 5. Let's see. So you have a circle that has a diameter with the following endpoints. And in part A, you want to find the center of the circle. Well, remember, if this is the diameter, so remember the diameter goes through the center. So if I want to find the center of this circle that has these endpoints on the diameter, then I just use the midpoint formula. So in part A, we're going to use the midpoint formula. And so remember, the midpoint formula is x1 plus x2 divided by 2. So you add your x's together, divide by 2. And then you add your y coordinates together and divide by 2. And so it's a good idea to label this x1, y1, and then x2, y2. So here's my first point, here's my second point. And so the center of this circle will equal, all right, so 2 plus 4 divided by 2, comma, and then negative 5, add the y's, negative 5 plus a negative 3 divided by 2. Simplifying this, 2 plus 4 is 6. 6 divided by 2 is 3, right? A negative 5 plus a negative 3 is a negative 8. Negative 8 divided by 2 is a negative 4. So there's your center of the circle. All right, part B, you want to find the length of the radius. All right, well, remember, one way to find the length of the radius, you're told that these are the endpoints of the diameter. So you could do it several ways. You could use these 2 points, or you could use one of these with this one because that's the center. Okay, it does not matter. Because of the time that we have, I'm just going to go ahead and use the diameter. So I'm going to find the length of the diameter, all right, and to do that I need to use the distance formula. So distance, remember, is the square root of x2 minus x1 squared plus, and then y2 minus y1 squared. So you're going to subtract the x coordinates from each other and then square it, subtract the y coordinates from each other and then square it, add them up, and then take the square root. All right, so we're finding length of the diameter now because I'm using these 2 points. So these 2 points are the endpoints of the diameter, so I'm finding the length of the diameter now. If I were using one of these with the center, I'd be finding the length of the radius. But the reason I'm using this is because, just to remind you, you could have made a mistake here, and that would not have been the center, and then the length of the radius would have been incorrect. So that's why it's a good idea to always use the original problem, information from the original problem, because you could have made a mistake along the process. Okay, so I get the diameter is going to, the length of the diameter is going to equal the square root of, all right, x2, so 4 subtract 2 squared plus, and then negative 3 subtract a negative 5 squared. Okay, all right, simplifying the radicand, 4 subtract 2 is 2, so this becomes 2 squared plus, now be careful here, this is negative 3 subtract negative 5, right? Well, you all know that that means negative 3 plus 5, which is 2. So this becomes 2 squared. Well, 2 squared is 4, and another 2 squared is 4, and so I get the square root of 8. All right. Now, that's the length of the diameter, but I want to find the length of the radius. Well, remember, the length of the radius is half the diameter. So the length of the radius will be the square root of 8 divided by 2. So that's the length of the radius. And leave it like that. If you can go ahead and simplify the square root of 8 here if you want to. But I'm going to leave it like that. All right, so you could say, remember, the square root of 8 is the square root of 4 times the square root of 2. So that's 2 square root of 2. So you get 2 square root of 2 divided by 2, which is equal to square root of 2. All right, so you could write it like this, or you can write it like that. All right, so remember that these two are the same. Okay, now part C. You want to find the standard form of the equation of a circle. Well, remember, the standard form of the equation of a circle is x minus a squared plus y minus k squared equals r squared. Okay, and so in this case I know hk. Hk is the center, which is this. All right, so here's my h, here's my k. So this becomes x minus 3 squared plus y minus k, which is a negative 4 squared, equal r. And it doesn't matter which of these you use. I'm going to use this one because that's probably what many of you did use. So I'm going to go ahead and use this. So I'm going to use the square root of 8 divided by 2 squared. All right, now that's not the answer. You got to simplify as much of this as you can. So the answer is going to be x minus 3 squared plus, you are expected to know that y subtract negative 4 means the same thing as y plus 4. That's how you got to write it. Squared equal, and then let's talk about what I'm squaring here. So the square root of 8 divided by 2 squared means the square root of 8 divided by 2 times itself. Okay? Well, the square root of 8 times the square root of 8, that's the square root of 64, right? And the square root of 64 is 8. And then 2 times 2 is 4, and 8 divided by 4 is 2. All right, so that's 2 here. And there's your answer. You could have used this as well, right? Because look, just think about this. You'd have the square root of 2 here, and think the square root of 2 squared is equal to the square root of 2 times itself, which is square root of 4, which is just 2, which is what we had here. Okay? All right, so it didn't matter which one of these you used. The majority of you probably used this one, so that's why I did that. All right, that's number 5. Okay, number 6. Number 6 is where you had a system and you wanted to use substitution. Well, this is the easy kind because one of the equations, there's a variable that already has a coefficient of 1, and that's this one. So remember, step 1 is, if you're going to use substitution, is to pick one of these equations and solve for one of the variables. And so we all know that it's easy to get x by itself here. So step 1, you're going to get x equal negative 2 minus 2y. So you bring the 2y over, subtract 2y from both sides. Now step 2, once you do that, then step 2 is to go to the other equation, and in place of x, you're going to substitute this. So in place of x, you're going to substitute negative 2 minus 2y. So this becomes 3 times negative 2 minus 2y plus 4y equal 10. Okay? Now solving this linear equation, so notice I have a system with two variables, right? And now I'm in step 2, I only have an equation that has one variable. So we're going to solve for y. So distributing, 3 times negative 2 is a negative 6, 3 times a negative 2y is a negative 6y, plus 4y equal 10. Combining like terms, negative 6y plus 4y is a negative 2y, so negative 2y minus 6 equals 10. Adding 6 to both sides, I get negative 2y equals 16. Dividing both sides by negative 2, I get y to be a negative 8. So that is so far my solution to this system is y equals a negative 8. As an ordered pair, I didn't actually put this in ordered pair, but if I did, you would put negative 8 as the second coordinate. All right, so that's y. I got to solve for x though. So I got to go back to either one of these equations, it does not matter. But let me just remind you, if you're certain that you did step 1 correct, and just use step 1 then. Just use this right here. You know y is negative 8, so I'm just going to put y here. So now remember, now we're solve for x. Again, it didn't matter which one of these you use, but if you're certain that you did step 1 correct, then use that. So x equals negative 2 minus 2 times y, which is negative 8. So that's negative 2. A negative 2 times a negative 8 is a positive 16. Negative 2 plus 16 is 14. So there's your x coordinate. So x is 14, y is negative 8. As an ordered pair, you would say 14 comma negative 8. Okay, either one of those is fine. All right. Number 7 is where you want to solve this system by using addition elimination method. So the way to do that is to choose one of the variables and do something to those variables, to the equations, so that the variables are eliminated. Well, in order to get those variables to be eliminated, your coefficients have to be opposites. So let's talk about eliminating the x. So suppose you wanted to do that. Eliminate x. So some of you probably wanted to do that. So if I'm going to eliminate the x, the good thing about that is that one's negative, one's positive. And so all I have to do now is just get these coefficients to be opposites. So the least common multiple of 6 and 5 is 30, right? So let me go ahead and rewrite this over. Just rewriting the equation over. That's an negative 87, and then 5x plus 7y equal negative 28. All right, so if I want the coefficients of x's to be 30, then that means that I've got to multiply this negative 6 by 5. But I've got to do that to this equation, to the left side and to the right side. And over here, if I want this to be 30, I got to multiply this by 6. I got to say times 6 and then times 6. So don't forget, what you do to one side, you do to the other. Okay, now distributing, and you're going to need your calculator on the other side. But distributing, I get 5 times negative 6x is negative 30x. 5 times 5y is 25y. Negative 87 times, using the calculator, 87 times 5 will give you 435. But that's negative 435. All right, and then the second equation, if you distribute, you get positive 30x plus 42 plus 42y equal, and then when you multiply that, 28 times 6, 28 times 6, but that's going to be negative 168, right? Okay, so that's where I'm at. Now, the next step, see these are opposites, so the next step is to add. So when I add these two equations, the x's are eliminated. And so 25y plus 42y is 67y. A negative 435 and a negative 168. So if you add that, 435 plus 168, you get a negative 603, correct? Negative 603. Dividing both sides by 67, I get y. So 603 divided by 67, I get 9. But it's a negative 9, right? Negative 9. So there is the y coordinate of my solution. So y, so far we know that the solution is that y equals a negative 9. But remember, just like the previous one, we got to solve for x. I got to figure out what x is. So here we have to go to one of those equations, it does not matter which one, and wherever I see the variable y, I need to substitute negative 9. I'm just going to go ahead to use the second equation. So we got to solve for x. Solve for x. So I'm going to use the second equation. And so wherever I see the variable y, I'm going to substitute negative 9. So I get 5x plus 7 times negative 9 equals a negative 28. Solving for x, I get 5x. Now 9 times a negative 7 times a negative 9 is a negative 63 equals negative 28. Adding 63 to both sides, I get, combining like terms, this is 0. I get 5x equal, and then use your calculator if you need to, a negative 28, negative 28 plus 63 equals a positive 35. Dividing both sides by 5, I get x to be 7. All right, so there's your solution. As an ordered pair, your solution is, make sure your x is first, 7 comma negative 9. Okay? Now, all right, now, so that was eliminating the x. Now, some of you probably went ahead and eliminated the y. So let's just go ahead and do that one just to see what you would have done. So we're going to go ahead and do this same problem again, but this time we're going to eliminate the y's. We'll get the same answer. Does not matter. So here was the system. So the system was negative 6x plus 5y equal negative 87. And then 5x plus 7y equal negative 28. All right, so this time we're going to go ahead and eliminate the y's. So let's do it that way. Eliminate y. Okay, so the least common multiple of 7 and 5 is 35, but notice this time they both have the same sign. So when I'm going to go ahead and rewrite the equations. So when I go ahead now and multiply both equations by a number, I have to make sure that one's negative and the other one's positive. So 5 times 7 is 35, and 7 times 5 is 35. But remember, what I do to one side, I do to the other, right? 7 times 5 times 5. But be careful, you need these to be opposites, so it doesn't matter which one of these is negative. I'm going to just go ahead and make the 7 negative. Okay. Now distributing, I get negative 7 times 6x is a positive 42x. Negative 7 times 5y is a negative 35y equal, and then use your calculator. A negative times a negative is a positive, so 87 times 7 will equal 609. All right, so that's 609. All right, second equation, 5 times 5x is 25x. 5 times a positive 7y is a positive 35y equal. A negative times a positive is a negative, right? And that's going to be 28 times 5, which gives us 140, negative 140 in this case. Now I can add them. Okay, so when I add those, the variables y add up to be 0. Those are opposites. So 42x and 25x is 67x equal 609, subtract 140 gives us 469. All right, now solving for x, I'm going to divide both sides by 67. I get x to be, so 469 divided by 67 equals 7. So my x coordinate is 7, which I knew was 7, right? Just from the other procedure, right? Okay, so x equals 7. So that's your solution so far. Now we got to find what y equals. So again, it does not matter which of these equations you use. I'm going to go ahead and use the first one this time. So if x is 7, so we got to solve for y. So if x is 7, I get 5 times 7 plus, I say we're going to use the first one. So I get negative 6 times 7 plus 5y equal negative 87. Well, negative 6 times 7 is a negative 42 plus 5y equals negative 87. Solving for y, I need to add 42 to both sides, right? What I do to one side, I do to the other. So that's 0. So I get 5y equal, now negative 87 plus 42. Use your calculator if you have to. Negative 87 plus 42 equals negative 45. Dividing both sides by 5. 5 divided by 5 is 1. 1 times y is y. And negative 45 divided by 5 is a negative 9. And that's what we had previously. Right here. Okay? And so this is negative y equal negative 9. As an ordered pair, again, as an ordered pair, just make sure the x-coordinates listed first. So x is 7 and y is negative 9. All right, so that was number 7. All right. Number 8. So let's get number 8. All right, number 8. Let's see what we have. Number 8. Okay, number 8. Okay, so in number 8, you want to find the difference quotient for the following function. All right, so the formula for finding the difference quotient is this. It's f of x plus h minus f of x divided by h. All right, so that's the difference quotient formula. And so if I'm going to apply this function, this formula to this function, we're going to do this in steps. So remember, step 1 is to find this. So just do it in steps. It helps if you do it that way. So step 1, we're going to find f of x plus h. Now what that means, remember, is where we see the variable x, here and here, I'm going to substitute x plus h. So this becomes 4 times x plus h, but remember I'm squaring it. So I'm replacing this with this, but you got to square it. So you see 4, replace, square, 4x squared. Minus 7, replace, x plus h, minus 1. All right. Now be careful. You got to remember the order of operations. You have to square first and then multiply. So don't distribute first and then square. That's mathematically incorrect. So you got to square first and then multiply. So we get 4 times. All right. So remember, x plus h squared. That means x plus h times x plus h. So I'm going to FOIL this. And so I'm going to get x squared. X times x squared. The outer is xh. The inner is also xh. And the last, h times h, is h squared. Combining like terms, I get x squared plus 2. See, xh plus xh is 2xh plus h squared. So that goes here. So that's 4 times x squared plus 2xh plus h squared. I'm going to go ahead and distribute the negative 7 here. So now you may say, well, why is it you can distribute it here, but you couldn't distribute here? Well, it's because here that exponent's 1. So x plus h to the first power is x plus h, and you just multiply by 7. So technically, you're still using the power. You're still doing the exponent first. X plus h to the first is x plus h. All right, so it still applies that we did here. Remember, you got to do the exponent first, and then you distribute. All right, so I get minus 7x minus 7h, and then minus 1. Distributing the 4 here, I get 4x squared. 4 times 2xh is 8xh. 4 times h squared is 4h squared minus 7x minus 7h minus 1. Okay, so that's step 1. That's just this. Now remember, step 2, if you're doing it in steps like this, which is what you were asked to do, because it does help your logical thinking. Step 2, you got to find f of x plus h minus f of x. So you're finding the numerator. But remember, this part you already found. That's step 1. So just rewrite this here. So this is what you just found. So that's going to equal 4x squared plus 8xh plus 4h squared minus 7x minus 7h minus 1. Now be careful. You're subtracting now f of x. And f of x is more than one term. So you got to put that in parentheses. So f of x is 4x squared minus 7x minus 1. So that goes here. Now the next step is to get rid of the parentheses. So you're gonna take the opposite of each of these terms, or distribute a negative 1. So I get 4x squared plus 8xh plus 4h squared minus 7x minus 7h minus 1. And then the opposite of 4x squared is a negative 4x squared. The opposite of a negative 7x is a positive 7x. And the opposite of a negative 1 is a positive 1. Now remember, at that point, every term that does not have a factor of h, its opposite better be located on the other side. So 4x squared, negative 4x squared, that's 0. That has an h, a factor of h. That has a factor of h. In fact, it has two of them. This does not. So a negative 7x plus 7x is 0. Those are opposites. You add them up, you get 0. This has a factor of h. This does not. Negative 1, positive 1, you get 0. What's left, notice these three terms. 1, 2, 3. They all have a factor of h. So let's go ahead and factor it out. So I'm going to rewrite it as h times 8x, right? So you factor out an h. Plus h times 4h is 4h squared, and then minus 7. All right, so that's step 2. And then finally, step 3 is to take that numerator, which is step 2, and divide by h. So step 3, you're going to take the what you got in step 2. So h times 8x plus 4h minus 7, divide by h. Then reduce, and you get 8x plus 4h minus 7. And that is the difference quotient for this function. So the difference quotient for this function, applying this difference quotient to this function, gives you this. Now this means something. You're going to learn about what that means in calculus, but that's what we have. So the answer is going to be 8x plus 4h minus 7. All right, so that's number 8. Okay, let's look at the next problem. So let's look at number 9. Number 9. Okay, so let's see what number 9 is. Number 9. Okay, so number 9, you want to determine which, for each of the following, indicate whether the relation is a function or not a function. And so part A and B, those are fairly easy. You had this in a previous course. Basically, you have a finite set of ordered pairs. And so we can look at this in terms of a mapping. So let's do part A right here. So this is part A. And so this is the domain, this is the range. So when x is negative 7, my y value is 2. Remember the definition of a function: for each x coordinate, there's only one y coordinate associated with it. And so far we're good. When x is 0, my y value, when x is 6 rather, my y value is 0. When x is negative 7, my y value is 1. Now be careful. Don't list negative 7 again. Only list it once. Because if you do it again, you're not going to think about this properly. So when x is negative 7, my y value is 1. Now right away you can stop, because you just realized that this relation is not a function, because when x is negative 7, there are 2 y values. So right away that's not a function. So for each x coordinate, there's got to be only one y value associated with it. Okay? Same thing in part B. So do that same idea. Domain, range in terms of this mapping. That does help. And so when x is 0, my y value is 1. When x is 2, my y value is negative 4. When x is negative 8, my y value is negative 2. When x is 4, my y value is 6. And so that relation is a function, because for each of these x coordinates, there was only one y value attached to it. So this is a function. So we just write the word function. Okay, in part C, now some students have trouble when an equation is given, when the relation is written in terms of variables. So let's look at part C. The way I would have done part C is two ways in this case. I know what the graph of an absolute value looks like. Remember, that's that V, right? So and you in one of the My Math Lab lessons, you had to graph something like this. So you know that when you graphed this, the y equals the absolute value of x plus 1, you had something that looked like this. So if you knew that, then you know that it passes the vertical line test, right? And so therefore this is a function. If you do not see it that way, then let's use a t-table. Use a t-table. And so we have y equals the absolute value of x plus 1. Okay, so using a t-table, when x is 0, I get y equals the absolute value of 0 plus 1, right? 0 plus 1 is 1. The absolute value of 1 equals 1. So when x is 0, my y value is 1. But you got to do a few more. If x is, let's say, 1, let's see what we get. When x is 1, I get y equals the absolute value of 1 plus 1. 1 plus 1 is 2, and the absolute value of 2 equals 2. So far we're good, right? For this x, there's one y value. For this x, there's one y value. When x is negative 1, let's see what we get. We get y equals the absolute value of negative 1 plus 1. Negative 1 plus 1 is 0. The absolute value of 0 is 0. Okay, so far I'm good, right? For this x value, there's only one y value. Let's go ahead and try, let's say 2. Let's try 2. When x is 2, I get, I'm going to have to do this here, y equals the absolute value of 2 plus 1, which is the absolute value of 3, which is 3, correct? So for this x value, I have one y value. Let's go ahead and try negative 2. Let's see what happens. When x is negative 2, I get y equals the absolute value of negative 2 plus 1. And negative 2 plus 1 is a negative 1. The absolute value of negative 1 is a positive 1. So I get negative 2, positive 1. And again, for this x value, there's only one y value. So you can continue on, but that's enough to realize, hey, this is going to be a function because for each of these x coordinates, there's only one y coordinate associated with it. So that's a function. Now, D is a little bit harder. You don't know what the graph of this looks like, so you have to use a t-table for that one. So let's talk about part D. So in part D, you have x equal y squared. All right. Now, the way I'm going to do this is so in place of y this time, I'm going to substitute a number. So if y is 0, see x is by itself. So if y is 0, I get x equal 0 squared, which is 0. So I get the point 0, 0. When y is 1, I get x equal 1 squared, which is 1. So I get the point 1, 1. When y is, let's say, negative 1, I get x equal negative 1 squared, which is a positive 1. Now this is where you can stop because notice when x is 1, what do you see? I get two y values. When x is 1, there are two different y values. So therefore, this is not a function. That's not a function. So not a function. Okay? All right. And in fact, you don't know what this looks like for the most part, but if you were to graph this, it would look like this. It would look like this. So it's kind of like a sideways parabola. And so notice it fails the vertical line test. It fails the vertical line test, so that would be not a function. Okay, so that's number 9. Now let's look at number 10. Okay, number 10. So in number 10, you're given that f of x is 3 minus 5x and g of x is this quadratic function. And you want to find g of 3. Now remember, these are two different functions. This is f, the function f, and this is a function g. So if I'm finding g of 3, then I've got to go to function g, and wherever I see the variable x, I'm going to substitute 3. So g of 3 will be, remember, you can substitute wherever you see the variable x, you substitute 3. So g of 3 is going to be negative 2 times 3 squared plus 4 times 3. Using the order of operations, 3 squared is 9. 9 times negative 2 is a negative 18. 4 times 3 is 12, right? So I get a negative 6. So g of 3 is equal to negative 6. All right, now this time, now remember we talked about this, that whenever you're evaluating a function at a number, you get a number. Here I'm evaluating a function at a variable expression, so I'm going to get a variable expression. Okay, now this time though, I got to go to my function f. So here's my function f. So this right here becomes 3 minus 5 times x. So in place of this x, I'm going to substitute 3x minus 4. Notice you got to use parentheses there. And then remember, you're going to multiply before you subtract, so distribute first. So I get 3, a negative 5 times 3x is negative 15x. Negative 5 times a negative 4 is a positive 20. Combining like terms, I get negative 15x. 3 plus 20 is 23. And there's your answer. So negative 15x plus 23. Okay? All right, number 11, you're given that this function g is just a finite set of ordered pairs, and you want to find g of negative 3. But remember, these are easy because g of negative 3 means what is the y value when x is negative 3? Well, here's where x is negative 3, right? So my y value is 0. Okay, now be careful here because this says negative 3 times g of 5. So let's look at g of 5. So g of 5 means what's the y value when x is 5? Well, when x is 5, my y value is negative 8. So this becomes negative 3 times negative 8, which is a positive 24. Okay, over here, you're adding g of negative 6 to g of 0. Well, g of negative 6, remember, that means what's the y value when x is negative 6? Well, when x is negative 6, that's right here, my y value is 1. So this becomes 1 plus, and then now g of 0. Well, when x is 0, the y that's here, my y value is 3. So 1 plus 3 is 4. Now over here, g of 4, so remember that means what's the y value when x is 4? When x is 4, that's right here, my y value is negative 1. Subtract 5 times g of 2. Well, what's the y value when g is 2? Well, when x is 2? Well, when x is 2, my y value is negative 1. So this becomes negative 1, subtract a negative 5. 5 times negative 1 is negative 5. And negative 1 subtract negative 5 means negative 1 plus 5, which is a positive 4. Okay? All right, so that was number 11. Okay, let's look at number 12. All right, number 12, you're given this function and you're asked to indicate the domain, the range, and so on. All right, so the domain, remember the domain is a set of x coordinates. And so let me go ahead and get a ruler. So when doing that, it helps if you use a ruler to guide you. So the domain is a set of x coordinates. So you're going to go from left to right. Notice though that this is an arrow on this side, this is an open circle. So when I go from left to right, this is where my function starts, although it is an open circle, which means that this point is not part of the graph. But I still must use it in my domain. Notice the domain, remember, is a set of x coordinates. So you got to look at your x coordinate. This is negative 8 right here. So this is going to be parentheses negative 8, parentheses because of the open circle. All the way, and just keeps on going, right? Because of the arrow, keeps on going all the way to infinity. And remember, when you use infinity, negative infinity, you're always going to use parentheses. All right, now finding the range. So remember, the arrow is going down. Find the range, you're going to go along the y-axis from bottom up. So the arrow think of this as this arrow pushing this ruler down. So you're going negative infinity. But now you're going to go up. So from negative infinity all the way, and this is where it stops, right? You can't go any further. Now that's a closed circle right here. That's closed. So that y value is 2. So you go from negative infinity to 2 with a bracket. Now it's a bracket because it's not an open circle. It's part of the graph. So that's closed. All right. G of negative 5. So remember, g of negative 5 means what's the y value when x is negative 5? Well, when x is negative 5, you got to find it. So you see this right here. So use the ruler to help you. When x is negative 5, look at this point right here. So if I label that point, that's negative 5 comma negative 4. So that's negative 5, negative 4. So when x is negative 5, that means g of negative 5 is going to be negative 4. Okay. Now this says, for what value of x is g of x equal to negative 8? Now you got to think of it this way. G of x means the same thing as y. So what they're asking you is when y is negative 8, what is the x value? That's the question. When y is negative 8, so along the x-axis find negative 8. Well, negative 8's here, right? Here's where negative 8 is. So when y is negative 8, so that's where my ruler touches the graph. So put a dot there and label it. Label that point. So that is 6 comma negative 8. So in y is negative 8, what's that x coordinate? Well, that x coordinate is 6. Okay? And then the next one, they want to know, indicate the intervals where the function's increasing. Well, remember, as you go from left to right, remember, g of x means the same thing as y. So where's y increasing is a question. So notice that my y values are increasing here, and then my y values are decreasing. So your function is increasing and then decreasing. But it helps if you kind of use colored markers or pens to help you with this. So notice it increases starting here, right, all the way to, and then ends here, right? So you see how I kind of put an interval here, parentheses around where it begins to increase and then it stops. Okay. Notice the x coordinates though. All right, so the x coordinates. Now, whenever you talk about increasing, decreasing, or constant, always use open intervals. So I'm going from negative 8, comma, to positive 4. So negative 8 to positive 4. All right. And then finally, number 13. So the last problem, number 13. So this time, it's kind of the same idea as before, except you have no arrows here. You have an open circle and an open circle. So they're both open. So let's talk about the domain. So remember, the domain is a set of x coordinates. So you're going from left to right. So notice that when I go from left to right, my ruler touches the graph here, but that's an open circle, but it touched that negative 6. So parentheses negative 6, comma. And then it stops here, right? And that x is 2. So 2 parentheses. Parentheses because it's open. So that point's not actually part of the graph. The range from bottom up. So when I go from bottom up, this is where I start touching the graph of this open circle. But that's 9 right here. See, that's 8, 9. That's 9. Open circle, 9. Oops, sorry, negative 9. Excuse me, negative 9. Sorry, negative 9. All the way to, and then it stops here, and that's a positive 7. All right, parentheses, because those are open circles. Then they want to know what's the value of f of 1. Well, remember, that means what's the y coordinate when x is 1. Well, locate x equal 1. So that's right here. Put a point where that is. So that's here. So that's 1 comma negative 7, right? So when x is 1, my y value is negative 7. So the answer is negative 7. Same thing here. When x is negative 4, that's right here, right? Negative 4. Use a ruler. Put a closed circle here. And so that point is negative 4 comma 3. So when x is negative 4, my y value is 3. And then the question, does f of x increase anywhere? Right, yes or no? Well, as you go from left to right, and remember f of x means y, your y values are getting smaller and smaller and smaller. So this function is not increasing anywhere. In fact, it's decreasing. So the answer is no. Okay? So that is the key to the makeup for test 2.